In this lesson, we'll be looking at transformations, and I first want to explain what transformations are, what we mean by that. So in the previous lesson, we looked at 8 different parent functions, and they're just pretty basic functions. And I'm calling them parent functions because nothing has happened to them. They have not been transformed, which is what we will be doing in lesson 10. So we're going to apply transformations to algebraic functions. For now, the algebraic functions we'll be applying it to are one of those 8 basic parent functions. And when I say transformations, that means things like shifting the graph up, down, left, right, stretching the graph, flipping it over the x-axis, flipping it over the y-axis, things like that. So we are going to be transforming those functions. So we have this table here. This table is going to summarize the 10 different transformations that we have. We're going to start off talking about the first 4 transformations, and the first 4 transformations are all shifts. And what I mean by shifts is it either shifts the graph up, down, right, or left. So in all of these examples that we're going to look at, we're always going to be starting with some original equation, y is equal to f of x. And so this is one of those 8 parent functions, any one of those 8 parent functions. So I have up Desmos here because this is going to help us graph these functions and to show us what's going on. So let's say that the parent function that I pick for my original equation is the absolute value of x. There's the graph of that. The next equation we want to graph, looking at number 1, says y is equal to f of x plus k. So my f of x was just the absolute value of x. I now need to look at the absolute value of x plus some number k. And let's just say that I chose k to be 3. And now we can see the new graph popped up in blue. So the original graph, the original parent function is in red. I can see some points that are on that graph, the original graph, like 0, 0, 1, 1, negative 2, negative 2. These are all points that were originally on the parent function. Then I graphed the new function, y is equal to the absolute value of x plus 3. And we can see just from looking at that what happened to the graph when we graph the new function. Well, the graph shifted up 3. So generally speaking, it is a shift up k, because if I would have added 4, then it would have gone up 4. So generally speaking, it is a shift up k units. So the graph shifted up 3 units. In general, it will shift up k units. How did the equation change? So that question is asking us, what is the difference between the first equation that we see in Desmos and the last equation that we see in Desmos? How did the equation change? Well, we added 3. Oh, let me not put 3. Let me put k. We added k outside of the function. And what I mean by outside of the function is I didn't add the 3 on the inside of the absolute value, right? So when I took this last equation here, I didn't put the plus 3 right there, right? I closed the absolute value and then I put the plus 3 on the outside. And then the last question is asking us, how do the points transform? So let's take a look. 0, 0 was on the original graph, but that's no longer there. Now we have 0, 3 on the new graph. We had 1, 1 on the original graph. That's no longer there. Now we have 1, 4 on the new graph. And we had negative 2, 2 on, oh, that says negative 2, negative 2. That shouldn't say that. It should be negative 2, 2. We have negative 2, 2 on the original graph, but then on the new graph, we now have the point negative 2, 5 on the new graph. So what's happening? What's the difference between these points? Well, the points are also moving up 3 units. And for the points to move up 3 units, we need to add k. In our case, k was 3. But we're only adding it to the y coordinates of the points. We're adding k to the y coordinates. So that's how our points are changing. Now let's take a look at this second row. I'm going to still choose the same parent function to start with. So I'm still going to start with the absolute value of x. But this time they tell me to look at y is equal to f of x minus k. So this time I'll look at the absolute value of x, let's say minus 6. So I just chose this time to choose 6 for my k value. And we can see how that graph in blue pops down that has now been shifted down 6 units. So in general, if we subtract k on the outside of the function, the graph will shift down k units. And I just answered the next box because the difference between the first equation in Desmos and the last equation in Desmos is that we subtracted instead of adding. So we subtracted k, and we did that on the outside of the function. And again, what I mean by outside is that minus 6 is not on the inside of the absolute value with the x. And then how do the points transform? I'm sure you can imagine, especially looking after our answer for the first one. But for example, negative 2, 2 is now at negative 2, negative 4. Because the graph moved down 6. So how we get the new coordinates is we, instead of adding, we subtract k from the y coordinates. So for all of the points that were on the original graph, for instance, 1, 1 was on the original graph. There's 1, 1 right there. That would have moved to 1, negative 5, because I take the y coordinate of 1 and I subtract 6 from it to get negative 5, since the graph is going down 6, and I can see that there. Now let's take a look at, so notice that those first two transformations shifted the graph up or down, and both of those transformations happened on the outside of the equation. So when we added on the outside, we went up. When we subtracted on the outside, we went down. If you look at the next two, number 3 and 4, so let me just label this here. This is outside. This is outside of the function. If we look at 3 and 4, here we're adding h, but that is on the inside of the function. And here we're subtracting h, but that is also on the inside of the function because that's happening on the inside of the parentheses. So let's look at an example with number 3 where we have f of x plus h. By the way, we already know that this notation, f of x plus h, means to replace x with x plus h. Let's say that I choose h to be 7. So I'm going to replace x with x plus 7. And let me change the color on this so it doesn't look like the exact same thing. Let's do purple. So here I've graphed the absolute value of x plus 7, and we can see what happened to the graph. The original graph is in red. The new transformed graph is in purple. What happened to the graph? Well, the graph shifted. Start with a shift. All 4 of these are shifts. The graph shifted left h units. I'm not going to put 7 because I could have chose any number, but I just chose, I just happened to pick 7 for h. But in general, the graph moved left h units. So how did the equation change? What's the difference between the first equation and the last equation in Desmos? Well, what happened is we replaced x with x plus h, right? Where there was an x right here on the inside of this absolute value function, this x that I'm highlighting there has now been replaced with an x plus 7. And I'm choosing to say that I could have written something like added 7 on the inside of the function or added h on the inside of the function. But with the things that happen on the inside of the function, I'm going to choose to use the word replace. And then the next question is, how do the points transform? Well, let's just take a look. 0, 0 is no longer on the graph of the new function, but negative 7, 0 is on the graph of the new function. 1, 1, that was a point that was on the graph of the original parent function, but now we have the point negative 6, 1 on the graph of the new function. So what's happening to these points is the points are also moving to the left 7 units, and in order to move to the left, I would need to subtract h from the x coordinates. And then the last row we'll look at is our last shift. And here we have an x minus h on the inside of the function. So let's see what it would look like if I looked at the absolute value of x minus 5. So I switched to minus and I chose 5, and we can see that the graph shifted right h units. I wonder if I can just type this. Yeah, the graph shifted right. I won't put 5. I'll just put h units. We can see that that's how the purple graph changed from the red graph. Let's talk about how the equation changed. It's going to be almost the exact same thing that we have right above it, except this time we replaced x with x minus h instead of x plus h. So here, how did the equation change? We replaced x with x minus h. And then the last equation, the last box is asking us how did the points change. So let's take a look. We have negative 2, 2 on the original graph in red, but that point's not on the new graph. Instead, the new graph is at 3, 2 because the point moved to the right 5. 0, 0 is no longer on the graph, but 5, 0 is on the new graph. And 1, 1 is not on the new graph, but 6, 1 is. So all of the points are moving to the right 6 units, and so how we're doing that is we are adding h to the x coordinates. So when we moved left, we subtracted h from the x coordinates, and when we moved right, we added h to the x coordinates. So these first 4 rows summarize all of the shifts up, down, right, or left that we can do to transform a graph. And the last thing I'll say about these 4, which will help us in the long run as we put everything from this table together, is notice that all of them were either adding or subtracting, right? They all had adding or subtracting. So just in general, shifts deal with adding or subtracting. Shifts are a plus or a minus. The things that happened on the outside of the function, the outside things happened vertically, because things that happen on the outside of the function will affect the graph vertically. The things that happened on the inside of the function happened horizontally. So when the h's were either added or subtracted inside the parentheses, the graph moved horizontally right or left. And they also happen kind of backwards. It happens counterintuitively. So I think our brain most of the time will tell us that if we're adding, we should go right, but that's not the case. If you add on the inside of the function, you go left. If you subtract on the inside of the function, you go right. So horizontal things will be happening counterintuitively as we look at transformations.